Yeah, good evening children. So welcome to Akshar Foundation. So this is Srinivas, so maths faculty. So coming to a previous class, in a number system we already we have discussed until the topics of prime numbers, right? Yeah. So let us continue with it. Prime numbers, after there are two types of prime numbers are there. We'll discuss about that also. So mainly twin primes. What are prime numbers? Numbers having only two factors are called prime numbers. So like example 2, 3, 5, 7, 11, 13 and so on. There are infinite set of prime numbers are there. In that, if you observe some prime numbers like 3 and 5, 11 and 13, 17 and 19, 29, 31. If you observe these two pair of primes, the difference between the numbers is 2. The difference between the numbers is 2. This type of primes are called twin primes. This type of primes are called twin primes. So simply the difference of primes is two. The type of primes are called twin primes. Example 3 and 5, 11, 13, 17, 19 and 20 and 31. Like that also will go. Okay, 41, 43 also. So these are called set of twin primes. Now coming to co-primes. And before that you already learned that 1 is the factor for every number, right? 1 is the factor for every number. Now here coming to the co-prime, if you take any two integers, the common factor between them only 1. That means there is no common factor between any two integers except 1. That type of primes are called co-primes, or we can call them as relatively primes also. Co-primes or relatively prime numbers. What are these? Common factor of two numbers is 1, only 1. That means there is no common factors between any two integers except 1. That type of numbers are called co-primes. Now here one important point is, while you are taking any two consecutive numbers, that means continuous numbers, the two numbers we can consider as a co-primes. Any two consecutive numbers are co-primes, like 101, 102. These two set of co-primes. 3 and 4, a pair of co-primes. Same like if you take any two consecutive numbers, we can take it as a co-primes because they have only one is the common factor. There is no other common factor between the two numbers. Okay? So twin primes and co-primes. Clear children? Right. And what is composite number and what is prime number we discussed in our previous class. Only two factors prime, more than two factors composite number. Yeah, please note it down. Only these points. Right. Next. Right. We discussed about that composite number now. Here one statement is, if you take any composite number means more than two factors. If you take any composite number, that composite number can be expressed as product of primes. That is fundamental theorem of arithmetic. That is called fundamental theorem of arithmetic. So every composite number can be expressed as product of primes. And the prime factorization is unique. This statement is called fundamental theorem in arithmetic. Okay na? Right. Now we'll discuss about the factors of some numbers. Let us see that factors. For example, factors of 24. That means we already discussed about what is factor and what is multiple. Now 24 will come in what are the tables? One table obviously, because one is common factor for every number. So one table 24 times. Two table 24 how many times? 12 times. Three table 24 8 times. 3 8s are 24. Four table 4 6s are 24. Five table won't come. Six table 6 4 24. 4 6s are 6 4s are same, it is repeating. So we are leaving like this. And the factors are 1, 2, 3, 4, 6, 8, 12, 24. Okay now? How many? 1, 2, 3. Overall, 8 factors. Okay now? So among them, 2, 3. Only these two are primes. These two are prime numbers. One is neither prime nor composite, remaining all composite numbers only. So these two are called prime factors. All are factors, among them only these two are prime numbers. So these two will be prime factors. Okay now? Very good. Now let us discuss about number of divisors, means number of factors or number of divisors for any number without doing this entire process. Because 24 is a small number, only 2-digit number, we can find it easily. Like 3-digit number is given. So for doing this, we feel somewhat difficult, right? So for that, there is a method to identify number of divisors or number of factors of a number. Okay, let us see that. Now I am writing that. Same example I am taking. 24 is a number, composite number, which is having some factors. How many factors? 8 factors. Let us find it. Here we are using prime factorization method. Prime factorization means we have to use only prime numbers to simplify this. That means a composite number can be expressed as product of primes here. Composite number can be expressed as product of primes. I wrote, right? Now 2 table, 2 is a prime number. 2 table 24 will come 12 times. Again 2 table 12. 6 times 2 6 are 12. Again 2 table in 6, 3 times. 3 is a prime number, 3 ones. So this 24 can be expressed as 2 into 2 into 2 into 3. 2 into 2 into 2 into 3. Here 2 how many times? 3 times. 2 cube. 3 how many times? 1 time only. So 3 power 1. 3 power 1. Now observe the exponents. Add both of them. So number of divisors is 3 plus 1. I am taking only exponential form. Exponent of each prime. 3 plus 1 and other exponent 1. 1 plus 1. So 3 plus 1 is 4. 1 plus 1 is 2. 4 2 is 8. So number of factors are 8. These 8 numbers. We can find by using this only number of factors, but we cannot say what are the factors exactly. Okay, na? I think we discussed already this topic in your previous class, so that's why I have written again. Now we go with Pythagorean triplet and perfect number, both. Yeah, coming to Pythagorean triplet. If L, M, N, these 3 numbers, these 3 are called Pythagorean triplet when they are in the form of L square plus M square equals to N square. L square plus M square equals to N square. That means square of first 2 numbers equals to square of third number. Sum of the square of first 2 numbers equals to square of third number. Then the 3 numbers are in the form of, are called Pythagorean triplet. Pythagorean triplet. Okay, na? Let us see the one of the example. 3, 4, 5. It should not be always continue numbers. I know one of the Pythagorean triplet, so that I am taking this. Let us find it. First 2 numbers. First number 3, second number 4. So same like 3 square plus 4 square. Let us see that. 3 square value. 3 square means 3 into 3. 9. 4 square value. 4 into 4. 16. 9 plus 16, 25. 9 plus 16, 25. This 25 can be expressed as 5 into 5. 5 has 25 only, no? Nothing but 5 square. See, 3 square plus 4 square we got 5 square. Then 3, 4, 5 are Pythagorean triplets. 3, 5, 4 are called 3, 4, 5 are called Pythagorean triplets. Okay, until then we got it, right? But sometimes to create or to find some more Pythagorean triplets, all the numbers in the triplet follows one condition. All the numbers in the triplet follows a condition. That means they are in the form of 2n, n square minus 1, n square plus 1. 2n, n square minus 1, n square plus 1. First 2 numbers, that means exact form can be changed. That means 2n, n square minus 1 can be changed sometimes. That means position of first 2 can be changed. Okay? Where n value is greater than 1 for all the natural numbers. For all natural numbers, n value you have to take greater than 1. Let us find if n value is 3. 3 is greater than 1 or not? Yes, 3 is greater than 1. We can take any one of the value. Now substitute. Let us find 2n value. N value 3, then 2n value. 2n means 2 into n. So 2 into 3, 2, 3, 6. Yeah, 2n value is 6. Now n square minus 1. 2n completed, now n square minus 1. N value 3. 3 square minus 1. 3 square means 3 into 3, 9. 9 minus 1, 8. Next, n square plus 1. That means 3 square plus 1. 3 square value 9. 9 plus 1, 10. So 6, 8, 10. This is also one of the Pythagorean triplet. Okay, na? If the numbers are in the form of L, M, N, should follow the condition L square plus M square is equal to N square, then those numbers are called Pythagorean triplets. Okay, we are checking like that. If to write one more Pythagorean triplet, we are using like this. N value should be greater than 1. We are using in the form of 2n, n square minus 1, n square plus 1. Because in the each number in the Pythagorean triplet are in the form of this 2n, n square minus 1 and n square plus 1. Okay, children? Please note it. Next. Now take n value is 5. Same question, take n value is 5. So if n is equals to 5, n equals to 5, find the value. First 2n. That means 2 5s. N square minus 1 value. So n value is 5. N square means 5 square. 5 square minus 1. 5 square means 5 5 is 25. 25 minus 1, 24. Same way n square plus 1. 5 square plus 1, 26. Now 10, 24, 26 are Pythagorean triplets. Okay, na? Now one problem. Check 5, 12, 13 are Pythagorean triplets or not. Check Pythagorean triplets or not. Check this one. How to check? If you are taking like first one, I said that previous 3, 4, 5 Pythagorean triplet means first number square plus second number square gives the square of third number. Square of first number and square of second number, and their sum will gives the square of third number. Then we can say the three numbers are Pythagorean triplets. Now check for this one also. Yeah. What are the three numbers? 5, 12, 13. So let us check first two numbers. Sum of the squares of first two numbers. Sum of the squares of first two numbers. So first number square, 5 square plus 12 square. 5 square value how much? 25. 12 square value, 12 12s are 144. So answer is 169. So 169 must be what square? 13 square. That means sum of the squares of first two numbers gives the third square. So 13 square or not? Yes, 13 13s are 169. So therefore 5, 12, 13 are Pythagorean triplets. 5, 12, 13 are can see, right? Okay. Last step you write. Therefore, 5, 12, 13 are Pythagorean triplets. Okay? Yeah, please note that. Next, we have to discuss about perfect number. Perfect number. Okay. So simply, perfect number means if you add all the factors of a number, the sum will be double to the given number. The sum will be double to the given number. That type of numbers are called perfect numbers. Okay, now? So we are writing that sum of all factors and divisors both are same. Okay, now? Factors and divisors both are same. Sum of all factors of a number is double to the given number. Is double to the given number. That type of numbers are called perfect numbers. Let us see one example. Find it for 6. Write all the factors of 6. One table, yes. 1 is the common factor for every number. 1 obviously will come. 1, 6, 0, 6. For 2 table 3 times. Okay. 1 table we check, 2 table we check, 3 table. 3 table, 3 twos. Yeah, 3 twos are 6. 2 threes, 3 twos, both are same. It is repeating. Here stop checking for the remaining numbers. Finished. So therefore the factors are 1, 2, 3, 6. Only 4 factors. Try to add all of them. 1 plus 2 plus 3 plus 6. 1 plus 2, 3. 3 plus 3, 6. 6 plus 6, 12. So this is sum of factors. This 12 is nothing but sum of factors. Now see that sum of factors value are 12. 12 is exactly 2 times of the given number 6. So sum of factors is twice the given number. So we can say that 6 is the perfect number. 6 is the perfect number. Okay? Next, let us check for 28. Let us check it for 28. Yeah. 1 obviously. 1 table 28 times. 2 table 28 how many times? 14 times. 2 14s are 28. 3 table is not coming in 3 table. 3 9s 27, so it is not coming. 4 table, 4 7s 28. 5 table won't come. 6 table not coming. Again 7 table. 7 4s 28. 4 7s 7 4s. It is repeating. We can stop. So what are the factors? 1, 2, 4. These 1, 2, 4, 7, 14. 28. Add all of them. Add all of them. 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14, 28, 28 plus 28 is 56. So this 56 is exactly twice of the given number. So we can say that 28 is also a perfect number. And take any one of the number between 6 and 28, and any other perfect numbers are coming between 6 and 28. I hope only first perfect number 6, second perfect number is 28. Check if any number is coming or not. So until then, 6 and 28 are perfect numbers. Like some of the numbers also, some more numbers will come. You should check that. Okay, na? That is the perfect number what it is. Now we can also change the definition, like not exactly changing, except itself. That means if you remove the itself from the set of factors, the sum of all divisors or sum of all factors is equal to the given number. Okay, na? For example, if we remove 28, itself means 28 number we are taking, same number we are removing this. Sum of remaining factors, 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14 plus 14, 28. So it is equals to the given number. Like that also we can take. Sum of all factors of a number except itself is equals to the given number. That also called perfect number. That means just we are modifying like that. That means some of them are learning the double, some of them are learning to equal to them. So both are important. Okay, na? According to our convenience to understand the concept, that's it. Please note it. Next one, absolute value. Next one is absolute value. What is absolute value? If you take any integer a, I am using a small letter a. If you take any integer a, that integer we are keeping in the symbol of this between two line segments are 2. This symbol is called modulo. Okay, na? If a is any integer, I am writing here, if a is any integer, a is an integer, so modulus of a is a. Modulus of a is a, where condition is a value is greater than 0. A value is greater than 0. That means it is following two conditions. First condition, modulus of a is equal to a, and the second condition is modulus of a is equal to minus a, where a value is less than 0. A value is less than 0. Third, modulus of a is equal to 0, where a value is equal to 0. Okay, na? If an integer satisfies like that, that is called absolute value of it. Absolute value of it. Let us see one example. For For example, I am taking a value minus 5. Minus 5 is greater than 0 or less than 0 or equals to 0? Less than 0. What is the condition for less than 0? It becomes minus a. Modulus of a becomes minus a, where a is less than 0. Okay, now I am writing the same thing here. In the place of a, I am writing minus 5 because a value minus 5. The result is minus a. A means minus a. Minus a value what? Minus 5. So minus over minus become plus 5. Minus or minus become plus 5. So simply to remember that modulus of any number is always gives positive except 0, because we are not considering 0 is a positive number or negative number, neither positive nor negative. So minus 5 becomes 5. So absolute value always gives a positive. You can remember like that, but conditions are very important. Correct? Please note it. We'll discuss one more example on it. I'm taking a value minus of minus minus 7. If it is given like this, there is an involvement of 3 numbers. So simply it is nothing but minus or minus plus, plus into minus minus. So a value is minus 7. So it is less than 0. According to condition, modulus of a is equal to minus a, no? Modulus of a equal to minus a. So simply modulus of minus 7 is equal to minus of minus 7. Minus or minus become plus 7. Okay, for every negative integer, there exists a positive integer to learn, like additive inverse, same concept here. Yeah, just I am writing that what are the topics you learned today. So today we have discussed about twin primes. Just revise again. Twin primes difference is 2 between two prime numbers. Co-primes are relatively primes, both are same. We have to take any two numbers, there must be only one is the common factor, nothing else. That means in another way we can discuss that no common factor between two numbers except one, that numbers are called co-primes. Next, Pythagorean triplet. Perfect number we discussed. And absolute value. So in our next class, we are going to complete the first exercise. Means practice exercise is given now from the first chapter. We are going to complete that in the next class. So once we revise all the concepts, okay. And one more, like sum of first n even numbers, sum of first n odd numbers. This we discussed, I think so, in our previous class. Sum of first even numbers. n into n plus 1. Important formula, n can be any integer or any natural number. Same way, sum of first odd numbers, first n even numbers, here first n odd numbers is n square. These two also you have to remember once. Then we go through the exercise. Okay, children? Yeah, thank you one and all. Have a nice day.